So hi guys. Now having discussed acid-base titrations, it is time to discuss redox titrations. Redox titrations are titrations based on redox reactions. In redox titrations, a reducing agent is titrated against an oxidizing agent to quantitatively determine the composition of either reagent. We will learn of redox titrations using this question. Determine the average volume of potassium tetraoxomanganate 7 that will oxidize 25 milliliters of a solution which contains 12.26 grams of iron 2 tetraoxosulfate 6 in 500 milliliters of solution. Now, we've basically been asked to carry out a redox titration to determine the volume of potassium tetraoxomanganate 7 that will oxidize 25 milliliters of a standard solution of iron 2 tetraoxosulfate 6. Just like in acid-base titrations, we start by pouring the potassium tetraoxomanganate 7, which acts as our oxidizing agent, into the clean burette. After that, we pipette exactly 25 milliliters of the iron 2 tetraoxosulfate 6 solution, which acts as our reducing agent, and pour it into the clean conical flask. To the iron 2 tetraoxosulfate 6 solution in the flask, we add about 25 milliliters of tetraoxosulfate 6 acid. This acid is added to maximize the oxidizing potential of the potassium tetraoxomanganate 7. Now, since this reaction changes color on completion, there is no need for an indicator. All we have to look out for is the change in color of the iron 2 solution from green to faint brown. This will indicate the end point of the reaction. After that, we commence the titration proper. We run the oxidizing agent slowly into the reducing agent while swirling continuously. Once we notice a color change from green to faint brown, we turn off the tap and take the reading on the burette. As you can see, the volume of potassium tetraoxomanganate 7 used is 15.7 milliliters. Now, since this is the very first titration, we will call it the rough titration. Knowing the endpoint to be 15.7 milliliters, we will now perform 3 more titrations in order to get more accurate readings. On repeating the titration procedure, we have obtained 15.5 milliliters as the volume of potassium tetraoxomanganate 7 used in the first titration, 15.4 milliliters for the second titration, and 15.4 milliliters for the third titration. At this point, we strike off the rough titration and solve for the average volume of potassium tetraoxomanganate 7 used by summing up the first, second, and third titer values and then dividing by 3. Using this formula, we obtain the average volume of potassium tetraoxomanganate 7 used to be 15.43 milliliters. Basically, this means that 15.43 milliliters of potassium tetraoxomanganate 7 is required to neutralize 25 milliliters of the given iron 2 tetraoxosulfate 6 solution. If you paid attention to this lesson, you must have learned how to carry out redox titrations, as well as how they differ from acid-base titrations. In a future lesson, we'll use the values given and obtained in this lesson to solve some questions. Stay with me.